Oh my god, we need to have an axe by next week. Hurry up.
We don't have a forge.
Well, we could 3D print it.
We have a wham machine.
This is true. Pitter patter, let's get at her.
So this is WHAM. WHAM stands for Wire Arc Additive Manufacturing. It's essentially taking GMAW, which is gas metal arc welding, and we put it on our own in-house built gantry system. So we have this torch here, which we have from our Lincoln Electric welder, and we printed with our donated Lincoln Electric wire. We're also part of NSF Hammer ERC, which stands for Hybrid Autonomous Manufacturing, moving from evolution to revolution. So what we're trying to do is combine two manufacturing processes, ours being WHAM as well as forging. So that's why we decided to come up with the WHAM axe.
So this is our design. We decided to inspire it based off the Dayton and Michigan patterns of the American felling axe. Characteristically, the Michigan and Dayton patterns have wider cheeks, which makes it better for splitting American hardwoods. This blade is 6.5 inches long, 3 inches tall, 1.5 inches deep, with a blade length of 7 inches.
This is ER70S-6. It's a mild carbon MIG welding wire from Lincoln Electric, coated with copper, which is why it has this color. It has a couple of unique advantages for our process, mainly that it's easy to print with, has a low cracking susceptibility, and also has mechanical properties most similar to a 4140 steel, which will hit all our performance metrics. It should give us a very strong axe.
Now that we have the print on block, we got to separate the print from the block. And to do this, we're going to use a circular saw.
The circular saw did not work, so instead, I put an end mill to it.
This is one of several furnaces we'll be using to heat treat our axe. The goal of which will be to heat the blade of the axe, but not the body, up to 950 degrees Celsius. That way we'll austenize it and bring it down to martensite with an oil quench. Hopefully we'll be able to add a lot of hardness onto the blade and the cutting surface of the axe, while keeping the body as soft as possible.
Okay, so now we're in CSAM, which is known as the Swagelok Center for Surface Analysis of Materials here at Case Western Reserve University. This is where we've done our metallography. So we took an XI sample from our axe and we used this Struers auto polisher to actually look at the grain structure of our material.
Zoom with himself.